Greetings, friends. Take a moment to settle in as we dive into the fascinating topic of enhancing large reasoning models with dynamic knowledge retrieval. Today, we'll explore an innovative research paper titled Search-o1, Agentic Search-Enhanced Large Reasoning Models, brought to us by the insightful researchers at Renmin University of China and Tsinghua University. You might be wondering, what exactly does all that mean? Let's unpack it together. Large reasoning models like OpenAI's O1 are sophisticated AI systems designed to tackle complex problems by breaking them down into a series of logical steps, a technique known as chain-of-thought reasoning. These models have been extensively trained using large-scale reinforcement learning, a method where the model learns optimal strategies through trial and error across numerous iterations. Despite their impressive capabilities, these models can experience what we call knowledge insufficiency. This occurs when the model's internal knowledge isn't sufficient to confidently proceed during the reasoning process, leading to uncertainties or potential errors. Imagine a seasoned professor attempting to answer a question but realizing they lack a crucial piece of information. That's knowledge insufficiency in action. To address this challenge, the researchers developed a new framework called Search-o1. This framework enhances large reasoning models by integrating two key components: an agentic retrieval-augmented generation mechanism and a reason in documents module. Let's delve into these concepts. The agentic retrieval-augmented generation mechanism empowers the model to act autonomously, hence the term agentic. When the model encounters a gap in its knowledge during the reasoning process, it can generate specific search queries to retrieve relevant external information. Essentially, the model gains the ability to decide on its own when and what to search for, much like an inquisitive student who knows when to ask questions to deepen their understanding. However, simply retrieving information isn't enough. The documents obtained can be lengthy and filled with extraneous details, which might overwhelm the model or disrupt its logical flow. This is where the Reason in Documents module comes into play. Operating independently from the main reasoning chain, this module carefully analyzes the retrieved documents, distills the pertinent details, and produces refined information. This refined knowledge is then seamlessly integrated back into the model's reasoning process. Think of it as having a trusted research assistant who sorts through vast amounts of information and hands you exactly what you need to proceed. By combining these components, Search-o1 enables large reasoning models to dynamically supplement their internal knowledge while maintaining coherence and logical consistency in their reasoning. The model doesn't just rely on pre-existing knowledge. It proactively fills in the gaps by accessing and incorporating external information as needed. The researchers conducted extensive experiments to evaluate the effectiveness of Search-o1 across various challenging reasoning tasks. These included complex problems in science, mathematics, and coding, domains that often require specialized and detailed knowledge. They also tested the framework on 6 open-domain question-answering benchmarks, which involve responding to questions that may require synthesizing information from multiple sources. In their preliminary experiments, they observed that without dynamic retrieval, models frequently expressed uncertainty. For instance, When tackling difficult problems, the models averaged over 30 instances of words like perhaps in a single reasoning process. This highlighted the model's struggles with knowledge gaps and underscored the need for a mechanism to address this issue. With Search-o1, the models could actively seek out the missing pieces of information. When they encountered a knowledge gap, they generated targeted search queries to retrieve relevant documents. The Reason in Documents module then distilled this information, enabling the models to continue their reasoning more confidently and accurately. An important finding was that traditional retrieval methods, which typically involve a single problem-oriented search before the reasoning begins, did not effectively address the knowledge insufficiency. These methods are akin to gathering all your resources before starting a project and hoping you won't need anything else along the way. In contrast, Search-o1's Agentic approach allows the model to perform multiple focused searches throughout the reasoning process. This dynamic retrieval mirrors how humans often solve complex problems. We continually seek out new information as new questions arise. Moreover, directly incorporating retrieved documents into the reasoning chain without refinement proved problematic. The excess information could introduce noise and disrupt the logical flow, much like trying to navigate a conversation with too many irrelevant details. By refining the retrieved information separately, the Reason in Documents module ensured that only relevant and concise details were integrated, preserving the coherence of the reasoning. The results of the experiments were compelling. In challenging reasoning tasks, Search-o1 outperformed models that relied on standard retrieval methods or those that did not use retrieval at all. Similarly, in the open domain question-answering benchmarks, models using Search-o1 achieved higher accuracy, particularly in tasks requiring multi-step reasoning across diverse information sources. These findings have significant implications. By enabling large reasoning models to autonomously retrieve and integrate external knowledge during their reasoning process, Search-o1 enhances their ability to handle complex tasks more reliably. It addresses the limitations of models that rely solely on static internal knowledge, which can be outdated or insufficient for certain problems. In conclusion, the introduction of Search-o1 represents an important advancement in the development of large reasoning models. By incorporating dynamic retrieval and refinement mechanisms, we can mitigate issues of knowledge insufficiency and improve the coherence and accuracy of the reasoning process. This research paves the way for more reliable and versatile intelligence systems capable of tackling a wide array of complex problems. Thank you for joining me on this exploration of Search-o1 and the ongoing advancements in large reasoning models. I hope this discussion has illuminated how integrating dynamic retrieval mechanisms can enhance the capabilities of these models. Until next time, keep questioning and keep learning.